So today we will just go for some basic problem. धीरे धीरे अपनी ये intensity problem की बढ़ाएंगे. तो अब हमें problem ही solve करना है. So straight forward, we are just going to solve the problems. Okay, let's try to go for this. So step by step एक एक problem को करते जाते हैं. Start with a very simple problem, but yes, it is interesting. So suppose this is mass m1, this is mass m2, this is mass m3. The force is acting on this particular mass m1, and the F is given as 20 Newton. M1 is given as 5 kg. M2 is given as 3 kg. And M3 is equal to 2 kg. Okay. So you have to find the normal force behind M1 and M2, or reactionary force between M1 and M2 and M2 and M3. So we have to go for this equation. So very simple. We can find the acceleration. First, what you will do, you will just assume this whole mass as a composite system. Then we can find the acceleration of the complete system. Yes, because if you are giving the force, and these all surfaces are frictionless. So if you are giving the force, then what will happen? The whole thing will move with the same velocity and the same acceleration. You can assume the whole thing as a composite mass. So what will happen? F is equal to M1 plus M2 plus M3 into A. And what will be your F? That is your 20 Newton by 5 plus 3 plus 2. That must be equal to A. So A is equal to 2 meter per second square. It is very important that you have to first find value of A. Now we will draw the free body diagram of M1, because we have to find actually the normal force behind M1, M2 and M3. So what will be FVD for M1? You have force F. So you are pushing the M1. So M1 will push M2, then M2 will also push M1. Then this will be your N1. So this is your M1. So what will be the equation of motion for this one?
Minus N1 is equal to M1.
F minus N1 is equal to M1A, and A we have find. Okay. Now second, for M2. So for M2, what you will, so if you are, so M1 is pushing on this, so N1 is here, so N2 is here, it will always have pushing effect. And then M2 will push M3, then M3 will also push M2. That is N3. Okay. Sorry, this is N1 and this is N2. Sorry. So what will be equation of this one?
The N1 minus
N1 minus N2 is equal to M2A. And what about third one? Third one को कौन आगे लेके जा रहा है?
N2.
M2.
N2. So you have, this is your M3. So N2 is equal to M3A. So what is value of N2? N2 is equal to 4 Newton, isn't it? And N1 is equal to कितना आ रहा है? इससे निकाल सकते हो N1, यहाँ से भी निकाल सकते हो N1 from
10 Newton.
10 Newton.
M2A plus N2.
Huh?
Yes, 10 Newton.
10 Newton. So 4 Newton and 10 Newton. This will be your answer. Okay. Straightforward, simple question. Don't worry. So this type of question can come into your exam for 1 marks sometime. But thing is that how to write the free body diagram, this is very important. So let's try to go for next one, because these all are simple questions. So today we will just go for a very basic, very fundamental, where you have to just try to understand the nature of forces. Okay. Let's try to go for another very interesting. This is really very nice problem. What you have a plank, and this plank has a weight that is 100 Newton. So weight is given, means mass into G is given, and you have a 3 pulley. So there is 3 pulley is hanged something like this. So first pulley is like this. And on the second one, you have another pulley. This is hanged like this. And from there, you have another pulley. This is hanged like this. And you are pulling it with the some force F. Okay. This is your F. So what will be question? The question is, what will be the force F such that these planks have to hang horizontally? It will not move up, not move down. By the way, suppose I am taking this plank something like this and I am holding it with this some force F. Then how much force we need to hold it? सपोज
100
ऐसा
Newton.
करना रहता तो कितना फोर्स हमें लेना पड़ता? 100 न्यूटन उसको रोकने के लिए. So you need 100 Newton of force. That must be your F. But now look at here, if we are using the pulley. So why this pulley is so important? This is very interesting. Why you need this pulley mass system? Actually, mechanics is very interesting subject if you understand the core of that. And what is core of that? The core of that is that you have to increase the efficiency of a system. Means you have to use very less force and then you have to work more, less force, more work, and this type of thing must be there. So let us try to go for this one. Okay. Okay. So suppose this has tension T. Let's say this has tension T1. Let's say this has tension T2. And what will be this tension?
100 minus T1 minus T2.
What will be this tension? This is F. If this is
T2
F,
by-
then this is F. This is also F, isn't it?
ये
Yes, sir.
दिख नहीं रहा है.
अरे ये F है तो ये भी तो F ही होगा.
Yes, sir.
Same tension, है ना? If tension in this rope is F, then tension in this rope is also what? F. क्या है यार?
Yes, sir.
भाई ये अगर F है तो ये भी तो F ही होगा, isn't it?
Yes, sir.
F. So your first equation is T1 plus T2 plus F must be equal to what? 100 Newton. Now, if this tension is T, then this tension is also T,
Yes,
isn't it?
Yes, sir.
This is also T2 and this is also T1, isn't it?
Yes, sir.
इस रोप में टेंशन तो T1 ही होगा ना. इस पुली के लिए इधर आएगा, इस पुली के लिए ऊपर जाएगा, isn't it? Suppose this thing is there. पुली के लिए लिखोगे तो ऐसा रहेगा. दूसरे पुली के लिए लिख रहे हो तो ऐसा रहेगा, isn't it? So what is relationship between T2 and F?
Okay.
Hmm?
T2
T2 is equal to
Equal to T2 by 2.
T2 equal to 2F.
2F. Okay. And what about T1? T1 is
What
equal
about-
to 2T, 2T2, isn't it?
Yes, sir.
Look at here. This is your T1. This is your T2. This is your T2 for this pulley, isn't it? So T1 is equal to T2 and that will equal to what? 4F. So what will happen? You can use it and you will have T1 is equal to 4F plus 2F plus F is equal to 100 Newton. And then you have 7F is equal to 100 Newton. What is your F? 100 by 7. So now you can see, with the help of this pulley and mass, your effort is 1 by 7 time what you are using here. है ना? तो ये बताओ ऐसा क्यों नहीं करते थे कि बहुत सारे और पुली जोड़ दें? ऐसा क्यों नहीं करते?
System become more complicated.
Why it is will become more complicated? इसी तरह से 2f हो गया, 4f हो गया, T3 इज इक्वल टू फिर नेक्स्ट 8f हो जाएगा, इस तरह होता जाएगा. हाँ,
That would not be budget friendly.
सॉरी, दैट विल नॉट.
That will not be budget friendly for someone
Sorry.
to make.
आवाज नहीं आ रही है क्लियर.
So that
She's
will not be
saying that will
budget
not be-
friendly.
बजट फ्रेंडली, एग्जैक्टली. अरे भाई, एक लिमिट तक ही तो पुली लगाओगे. आर यू गेटिंग माई पॉइंट? सो वाई फाइनेंस एंड मैकेनिक्स वर्क टुगेदर. आर यू गेटिंग माई पॉइंट? एक लिमिट तक ही तो आपको है भाई, काम है सिर्फ होल्ड करके रखना. तो ऑब्वियसली 100/7 इज मोर देन एनफ. यू कैन यूज इट विद 2 पुली. ओके, कितना एफर्ट लगाना है, क्या लगाना है, ये तो हमारी नीड होगी ना. सो वाई दिस इज ड्यू टू, otherwise you can use n number of pulley, but every pulley have some cost, so why you have to use it. Are you getting my point? Anyway, this is just a joke. Let's go for next problem. Chalo. It's again very fundamental question, but very interesting. Okay, let's try to do this one. Just a minute, because numbers are very important. So why? Just a minute. Chalo. So what you have a mass, okay, and this mass has weight 40 Newton. This mass has weight 40 Newton. And the coefficient of static friction is equal to 0.5. And coefficient of kinetic friction is 0.4 Newton. And this is your, and you are applying the horizontal force. Okay. The question number 1. What is the limiting friction? What is limiting
20
friction?
20 Newton.
What is limiting friction? The limiting friction is
Newton.
equal to, what is
Newton.
limiting friction? F limiting is
Mu
equal
s
to what?
into
Mu s
W.
into n or mu k into n?
Mu s into W.
Mu s
s
into
into
n. And what will be n? This is your 40 and this will be n. So that value is equal to 20 Newton. Now, if you are going to apply F, applied force is 15 Newton. What is frictional force?
15 Newton.
15
Newton.
15 Newton. Is your applied force is 20 Newton. What will be frictional force?
20 Newton.
20 Newton.
20 Newton.
Very good. If your applied force is 30 Newton, what will be frictional force?
16 Newton.
Huh?
16.
16 Newton.
16 Newton.
How do you know? This is now,
New-
this is your applied force is more than limiting friction. So what will happen? So that value is equal to mu k into n, and that value is equal to 0.4 into n is 40, that will 16 Newton. Okay. Just a very fundamental question. So you have to always try to see whether you are using a static friction or kinetic friction. When you have to use static friction, when you have to use what? Kinetic friction. Okay. One of the very famous question in your textbook, +2 textbook, that there is a wedge theta. And this experiment, I think you have done into your +2 also. So you can vary the theta. and there is a coefficient of friction is, let's say, mu is the static coefficient of friction. So what will be the value of theta such that it will just fall down? This, and it has mass m. Okay, it will just fall down. What will be critical angle theta? Suppose you are horizontal, it will not falling, not falling, not falling, and now it is just going to fall down. What will
So
be that
theta
critical
equals
angle?
to tan inverse mu.
mg sin theta is equals to mu s n.
So that is how do you know? You will just go for mg. This is what? mg cos theta. This value is equal to what? N. And this value is equal to what? ये क्या हो जाएगा? mg sin theta. Now, so what is your external force? mg sin
sin
theta. Okay. What is your limiting friction?
Mu n.
Mu into n. Okay. So this is your static friction. So limiting friction is F limiting is equal to mu s into n. And what is this value? Mu s into, and what is n value? N will be equal to what? mg cos theta. So now for the critical point, the external force. What is external force here? External force is mg sin theta. So for the critical, F external must be equal to limiting force, limiting friction. That is your mu s mg sin theta. Okay. And what is this value? F external is, sorry, mg cos theta, na? Mg cos theta. That value is mg cos theta. And what is your F external?
mg sin theta.
Mg sin theta. So
Sir, mu s mg cos theta is frictional, limiting friction.
that is limiting friction, na?
So you have written F external.
Yes. When it is just going to slide,
Oh, okay.
F external is equal to what? Limiting friction.
Equation.
Limiting friction.
Okay, sir.
है ना? F external must be equal to what? mg. तभी तो हो पाएगा ये. And then what will happen? Tan theta is equal to mu s. ये क्वेश्चन मैं आपको यहां पर इसलिए करवा रहा हूं, ये आपके एग्जाम में नहीं आएगा. We will do the same question when we have a sphere here, isn't it? Or disk here. Then how this moment of inertia and all this thing will come into picture, that is very important. So अभी तो आपकी वैल्यू 10 कितना आ रहा है? tan theta is equal to mu s. Your tan inverse mu s theta की वैल्यू आएगा. But when you have rotation in this particular problem, then you will see how this is going to work. समझ में आ रहा है ये? तो वहां पर हम देखेंगे किस तरह से हम काम कर पा रहे हैं and how this torque will come into picture. Okay? चलो, let's try to go for next one. फटाफट क्वेश्चन सॉल्व करते हैं. चलिए. So what you have one plank, there is another mass, let's say it is capital M, it is small m, and this surface is frictionless. Okay, this surface is frictionless, but there is a coefficient of friction is mu, and that is a static friction. Okay, is mu. So you are applying the force in the lower mass. We are just going to apply the force on a lower mass. So what will be the maximum force F such that these two blocks move together? You understand? Minimum force की बात नहीं कर रहा हूं. Minimum तो बहुत थोड़ा सा force लगेगा, साथ साथ ही जाएगा. If you have some more force, then what can be possible? अगर ये force बहुत ज्यादा होगा तो क्या होगा? This will come.
M is moving backward.
M will move backward.
Backward.
Okay. So how you will approach this particular problem? So you have to find the F, limiting force of F, such that both the block will move together. This is one question. The second question is entirely different. This is the same thing, but here we are just going to apply my force on a upper mass. This is very interesting. Same thing. क्या दोनों का आंसर सेम होगा क्या?
So,
No.
एक में आप नीचे लगा रहे हो फोर्स और एक में आप ऊपर लगा रहे हो. What will happen? So we will just go for a
What is
equation
the
of
second question? Means first question, both the boxes are moving together, and in the second one,
both the boxes are moving together. Don't worry.
okay.
है ना? तारे कंडीशन सेम रहेंगे तभी तो कंपेयर करेंगे. ठीक है? Both the boxes will move together. This is my question. But in first, you are applying force on a downward mass, and here you are applying force on a upward mass.
तो सेकंड वाले में फ्रिक्शन कहाँ पर है?
दोनों में फ्रिक्शन यही है यार. क्या बात कर रहे हो? दोनों में फ्रिक्शन यही है. तभी अरे कंपेयर कर रहे हैं ना. थोड़ा तो दिमाग ओपन करके काम करो. ठीक है? चलो, म्यू दोनों का फ्रिक्शन है. ठीक है? Let's try to do this one. So if you are going to draw the free body diagram, what will free body diagram? This F will be in this side. What will be frictional force? In which direction you have frictional force? Huh?
Upper surface, backward direction.
For this, for particular M, in this side or left or right?
Left.
Left side. Why left? Why left?
Applied force के opposite direction में.
ये किसने कह दिया
Opposite
तुम्हें?
motion.
फोर्स के अपोजिट डायरेक्शन में
अरे ना
friction.
बाबा, फिर से सुन लो. You will ask a question. If there पढ़ाया था is not any friction, then what is possible motion? ये क्वेश्चन पूछोगे अपने आप से. क्या क्वेश्चन पूछोगे? If there is not any friction, then what is the possible motion? अगर कोई फ्रिक्शन नहीं है तो क्या पॉसिबल मोशन है? आर यू गेटिंग माई पॉइंट?
यस सर.
ये सवाल पूछोगे. चलो, अब किसके रेस्पेक्ट में मोशन देखना है? सरफेस के रेस्पेक्ट में. कौन सा सरफेस? कॉन्टैक्ट सरफेस. यस. अगर आप यहां खड़े रहते इसके ऊपर, तो ये मास किस डायरेक्शन में दिखाई देता मूव करता हुआ अगर कोई फ्रिक्शन नहीं होता तो?
सर राइट साइड.
टुवर्ड्स राइट. तो व्हाट विल बी फ्रिक्शनल फोर्स? टुवर्ड्स लेफ्ट. Are you getting my point? So you have F minus frictional force is equal to MA. This is your one question, one thing. Now let's try to go for first one. The ऊपर वाले पर देखो. ऊपर वाले पर फ्रिक्शनल फोर्स किधर लग रहा है?
अपोजिट सर. अपोजिट डायरेक्शन ऑफ.
इसके अपोजिट लगेगा. फॉर एवरी एक्शन यू हैव रिएक्शन. ये भी कर सकते हो. या फिर आप फिर से देखो. यू विल स्टैंड हियर एंड यू विल आस्क द क्वेश्चन, इफ देयर इज नॉट एनी फ्रिक्शन देन व्हाट इज द पॉसिबल मोशन? तो ये अगर इधर मूव करता हुआ दिखाई देगा इसके रेस्पेक्ट में, तो ये किधर मूव करता हुआ दिखाई देगा? लेफ्ट. देन फ्रिक्शनल फोर्स विल बी राइट. तो भाई इसको आगे कौन खींच कर ले जा रहा है? फ्रिक्शनल फोर्स खींच कर ले जा रहा है. आर यू गेटिंग माई पॉइंट? कौन एक्सेलरेशन? आप बार बार ये कहते हो कि भाई मोशन को अपोजिट, या तो मोशन दे रहा है, इसको खींच कर ले जा रहा है आगे, ऐसे खींच रहा है इसको. चलो भाई आगे बढ़ो. आर यू गेटिंग माई पॉइंट?
सर
हाँ,
प्लीज एक बार एफ बार की डायरेक्शन बताएंगे. नहीं समझ में आया. मतलब यहाँ स्मॉल एम के.
अरे भैया इसके ऊपर खड़े हो जाओ।
Yes. Okay.
अब इसके ऊपर खड़े हो तो ये पार्टिकल इधर मूव कर रहा है, तो ये पार्टिकल किधर मूव करेगा इसके रेस्पेक्टिव सरफेस के रेस्पेक्ट में?
Opposite.
अपोजिट।
Yes.
मोशन इधर होगा ना,
Yes.
तो फ्रिक्शनल फोर्स किधर लगेगा? इधर लगेगा,
Yes.
है
Clear.
ना? यहां नहीं लगेगा, यहां पर लगेगा बेसिकली। ठीक है, ओके। So this is your frictional force, and this frictional force is producing the same acceleration. Isn't it? And what will be frictional force? बताओ भाई।
into n.
Mu into n. And what is n? Small mg or capital mg or m plus mg? क्या होगा? What is frictional force here?
So small mg into mu.
So you can write this F is equal to frictional force, F minus frictional force. What is A? Frictional force by M into M. यही तो लिखोगे. What is frictional force now? बताओ. Mu into N is equal to MA. What is N? Mu into mg is equal to ma. यही तो होगा, isn't it? So your F minus frictional force is mu mg, and that value is equal to mu mg by m into m. So what will be F? Mu m plus m into g. ओके, फर्स्ट केस में तो ये आया। सेकंड केस में क्या होगा भाई, जरा देखा जाए। सेम आएगा या फिर डिफरेंट आएगा? देखते हैं, जस्ट ट्राई टू चेक इट। ठीक है ना, क्लियर है ये एवरीवन?
Yes, sir.
है ना? ओके, लुक एट हियर। सेकंड केस में देखते हैं, पहले ऊपर वाले पर ही लगा लो। दिस इज योर एम, फोर्स इधर लग रहा है, इसके रेस्पेक्ट में ये अब किधर मूव करेगा? टुवर्ड्स राइट।
Towards right.
Towards right. So frictional force will towards left. So you have F minus frictional force is equal to ma. Now नीचे वाला को क्या है? This is m. Where are your frictional force? Towards right or left?
Towards right.
Towards right. देख रहे हो इसको? And here frictional force is equal to what? M into A. What is your frictional force?
Mu into small mg.
Mu into small mg. Very good. Again, both time frictional force is same. Mu into small mg. So you will get it. What will be answer? क्या हो रहा है? F minus mu mg is equal to m into what is your A? Mu mg upon capital M. Isn't it? So what is your frictional force here? That value is mu mg. You will take common 1 plus m by m. Isn't it? This will be your answer. ठीक है?
Sir,
Hmm.
for the equation F minus FR equal to capital M into A in the first problem,
Hmm.
where I am standing?
Hmm?
Where I am standing for the equation F
क्या?
minus FR equal to capital into for this case,
Huh?
where I am standing?
Where you are standing?
You have said you were think you are standing on capital M or small m mass over.
अरे बाबा, I am saying only to direction of frictional force. Okay?
But for this case,
भाई
why
आप
FR?
एक मिनट, what is definition of frictional force? फ्रिक्शनल फोर्स का डायरेक्शन कैसे पता चलता है?
opposite of the to the motion.
Opposite to
of
not
the
motion, opposite to relative motion.
relative motion. Yes.
तो यहाँ
yes.
पर किसके बीच में रिलेटिव मोशन होगा?
M, capital M and small m.
स्मॉल एम. तो
हाँ.
इसका मोशन देखोगे तो किसके ऊपर बैठोगे? नीचे वाले का मोशन देखो तो किसके ऊपर बैठोगे?
ऊपर वाले के।
ऊपर वाले के ऊपर बैठकर देखोगे.
Okay. Okay. sir.
और कैसे रिलेटिव मोशन देखा जाता है? व्हाट इज मीनिंग ऑफ रिलेटिव मोशन?
Okay.
So always you have to talk about relative motion. Relative motion with respect to surface. Are you getting my point? जो contact surface, उस पे surface ही हटा दो, contact surface. Contact surface, ये दिमाग में रखना है आपको. समझ पा रहे हो? है ना? और हमेशा ये क्वेश्चन को एराइज करो, इफ देयर इज नॉट एनी फ्रिक्शन. आर यू गेटिंग माई पॉइंट? अगर कोई फ्रिक्शन नहीं होता तो क्या होता? ओके, इफ देयर इज नॉट एनी फ्रिक्शन, इफ देयर इज नॉट एनी फ्रिक्शन, देन व्हाट इज गोइंग टू हैपन? एवरीवन इज कंफर्टेबल? ठीक है ना? सो इस तरह से आप देख रहे हो. एंड नाउ यू कैन सी बोथ हैव डिफरेंट वैल्यू, है ना? यहां पर म्यू एम जी को कॉमन ले लें तो क्या आ रहा है? दोनों सेम आ रहा है क्या डिफरेंट आ रहा है?
Different.
डिफरेंट आ रहा है ना? ये सेम आ रहा है, जस्ट चेक इट.
इसमें कैपिटल एम ऊपर हो जाएगा, उसमें
इसमें कैपिटल एम ऊपर और इसमें कैपिटल एम नीचे हो रहा है भाई. सो दिस इज वेरी इंटरेस्टिंग, है ना? म्यू एम जी को कॉमन ले लो तो यहाँ स्मॉल एम नीचे आ रहा है, वहां पर कैपिटल एम नीचे आ रहा है. तो जहां पर आप फोर्स लगा रहे हो वो बहुत ज्यादा काम कर रहा है. आर यू गेटिंग माई पॉइंट? सो इट इज वेरी इंपॉर्टेंट कि आप किस तरह से देख रहे हो, कहां फोर्स लगा रहे हो और उसका क्या इफेक्ट हो रहा है. ओके, सो दिस इज वन ऑफ द नाइस क्वेश्चन, +2 का वन ऑफ द ब्यूटीफुल क्वेश्चन है ये, फ्रिक्शन को समझने के लिए. चलो लेट्स गो फॉर वन मोर. आज मैंने सिर्फ सिंपल क्वेश्चंस रखा है. नेक्स्ट क्लास में हम लोग जो है, नेक्स्ट क्लास जब भी होगी आपकी, देन वी विल गो फॉर सम मोर इंटरेस्टिंग क्वेश्चन जो जेस्ट TIFR के लेवल की क्वेश्चंस होंगे. ओके, बट उसके लिए आपको, एंड यू विल ऑलवेज सी दैट इन मैकेनिक्स द सिंपल थिंग इज वेरी इंपॉर्टेंट. कॉम्प्लिकेटेड प्रॉब्लम है, बस ज्यादा कुछ नहीं, ज्यादा रिजॉल्व करना होता है बस, और कुछ नहीं, बट कॉन्सेप्ट इज एग्जैक्टली सेम. ओके, सो दिस इज योर रिजिड वॉल. क्या है ये? रिजिड वॉल. दिस इज योर मास m and you are applying some force F vertically, है ना? Sorry, horizontally apply करो. This is vertical. Horizontally you are applying some force F. So what should be the minimum force F such that it will not fall down? And the coefficient of friction is mu s. What will be the minimum force F such that this will not go down?
F equals mu mg.
F is equal to mu mg. How do you know? So you have free body diagram. This will be mg. What is the direction of frictional force?
Upward.
Upward direction. How do you know? यहाँ तो कोई मोशन तो हो नहीं रहा है.
Body, because the body is moving.
तो फ्रिक्शन नहीं होता तो बॉडी नीचे
Can
गिर
move.
जाता है.
अरे भाई फिर से ये क्वेश्चन पूछोगे ना, इफ देयर इज नॉट एनी फ्रिक्शन. मैं बार बार बोलता हूं तुम्हें ये क्वेश्चन पूछने अपने आप से. इफ देयर इज नॉट एनी फ्रिक्शन, आप इन्फिनाइट अमाउंट ऑफ फोर्स लगा लो, ये रुकेगा नहीं आपसे. आर यू गेटिंग माई पॉइंट? If there is not any friction, this mass is bound to fall down, isn't it? So what is possible direction of friction? जो भी मोशन हो रहा है उसके
Down.
अपोजिट. this will be your frictional force. So now your mg is equal to frictional force. What is your frictional force?
U into F.
Mu into n. यही तो होगा. And what is your n?
F.
N is equal to F. So you have mg is equal to mu into F. Then F is equal to what? Mg by mu. Are you getting my point? So एक होमवर्क लो और उसको करके भेजो. अब मैं फोर्स क्या कर रहा हूं, सेम m है, there is mu is there, you are applying some force F with angle theta. So what will be minimum force such that this mass will not fall down? Question clear है ये? What will be minimum force F such that this block is not fall down? So you have to go for this problem. तो आज के लिए इतना ही रहने देते हैं. नेक्स्ट क्लास में हम लोग और भी कुछ प्रॉब्लम करने की कोशिश करेंगे. ठीक है, नेक्स्ट क्लास में हम लोग इसको फिनिश ही करेंगे, इस चैप्टर को मोर और लेस with some more intense problem. Today we have just done some basic problem. ठीक है, so just send me on your WhatsApp group. Clear है ये? Okay, thank you.
Thank you, sir.
Thank you, sir.
Thank you. Practice हो रहा है.